Welcome back. The problem is at equilibrium in Haber's process, the partial pressures of nitrogen, hydrogen, and ammonia gases are respectively determine the number of undissociated moles of nitrogen present. Now we have to understand this problem. We have been given the partial pressures of gases, all the gases involved in a process, and we have been asked to find the number of undissociated moles of a single gas at equilibrium. In other words, we have to find the concentration at equilibrium. So what is the connection of mole fractions to partial pressures? The partial pressures and the mole fractions, they are interrelated. So if the total pressure is there by all the constituent gases, suppose we call the total pressure as P. In that case, mole fraction into total pressure will equal to the partial pressure of that gas, in this case nitrogen. So partial pressure of nitrogen would be equal to mole fraction of nitrogen into total pressure. So that is the correlation. So in order to find the number of moles, that is the concentration of nitrogen, we have to find the mole fraction first. And in order to find the mole fraction of nitrogen gas present, how we have to proceed? How we do proceed? We proceed by the way of writing the IC chart. So let me explain this chart. This is a concentration at different stages: initial concentration, then at equilibrium. Now this process is reversible. In the beginning, in Haber's process, nitrogen and hydrogen are present. They combine in the ratio of 1:3, and then they form 2 correspondingly moles of ammonia. Okay, so in the beginning, what would be the concentration and of what gas? So nitrogen is present in 1, hydrogen 3, and what is the data about ammonia? Nothing. It is a product, so nothing in the beginning. So as the reaction proceeds, we will assume that X number of moles are utilized. X number of nitrogen moles are utilized. So the number of moles utilized, nitrogen X, then hydrogen correspondingly 3x, nothing about ammonia. So now what would be the undissociated or unreacted nitrogen? So initial concentration minus the utilized number of moles, 1 minus x. This is the undissociated or unutilized number of moles. Same is about hydrogen. 3 were there in the initial stages and 3x were utilized. So unutilized are 3 minus 3x. What about ammonia? How many ammonia undissociated are present? So the obvious 2x, 1x from 1 mole of nitrogen, 2 moles of ammonia are formed. Therefore 2x are there present over there. X will give rise to x number of moles when utilized will give rise to 2x number of moles of ammonia at equilibrium. Okay, that is there. Now in order to find, our target is to find the mole fraction. So in order to find the mole fraction, we know how much is the total number of moles. What are the total number of moles? So coming here, total number of moles. How many moles of nitrogen? 1 minus x. how many moles of hydrogen? 3 minus 3x. And how many moles of ammonia? 2x. If we sum up all these three, we get total number of moles present at equilibrium, that is 4 minus 2x. Total number of moles at equilibrium of all three gases. And why are finding with this figure? We are finding out this figure because that is being used to find mole fraction of nitrogen. So given information, now we are going to use and substitute in this formula. So now the first quantity which we will find out is this. Total pressure is sum of partial pressure of nitrogen, hydrogen and ammonia, and that is equal to, as we know, 0.83 plus 2.5 plus 1.66, which equals to 5 atmosphere. This is the total pressure, and we have been asked to find what is the undissociated number of moles. In other words, we have to find what is 1 minus x. How much? Okay, so we'll find first the value of x and then we'll proceed to find what is 1 minus x. So substituting the value of partial pressure, that is 0.83 nitrogen partial pressure, will be equal to mole fraction of nitrogen into total pressure, that is 5. So mole fraction, rewriting that thing again, 0.83, that is equal to 1 minus x divided by 2 into 2 minus x multiplied by 5. So 0.83 divided by 5 is equal to 1 minus x divided by 4 minus 2x. Simplifying further, you bring this side and you get x is equal to 0.5. But we have been asked to find what is the number of undissociated moles at equilibrium of nitrogen, and that is equal to, as we have seen earlier in the chart, 1 minus x. Substituting the value of x, as we know, 1 minus 0.5, we get answer is equal to 0.5, and this is our answer.